Let's take what we've learned and apply it to some actual riding situations. We're going to look at different choices of wheels for different situations. Carbon, deep section, heavy, light, whatever. And look at some different scenarios of centuries, challenging club rides, road races, time trials, triathlons, and criteriums. And I'll try to give you some advice on what wheels are good for which situations. We'll compare two-wheel options. Option one would be an aluminum clincher racing rim. An aluminum clincher racing rim might weigh about 400 grams, nice and light, might have a depth of about 20 millimeters. If we compare that to a carbon clincher racing rim, we find there that we have a weight of maybe 600 grams. So the carbon rim is heavier, but we saw before that it might nevertheless be faster if it's more aerodynamic. And this one here has a depth of 60 millimeters. So our question is, for different situations, which rim is going to be better in our wheel, the aluminum rim or the carbon rim? The aluminum is lighter, but the carbon is more aero. So which is going to be best in which situation? In the case of Centuries, which there are many, lots of these are popular fundraisers, club events, and so on, and lots of them around the country. The Seagull Century is one in Maryland. The Hilly 100 in Indiana, there are many. They're fundraisers for MS, Tour de Tour, and so on. For this type of a long ride, you're not doing a lot of braking, maybe no braking. So what's going to be best for you is going to be an aero rim, because the aero benefit is going to be more important than the weight penalty of the heavier rim. So your carbon fiber, aero, heavier wheels are going to be an advantage in this type of a Century ride. Challenging club rides, maybe you do this on weekends, maybe you do this at lunch. Once again, limited braking. Again, the aero wheel is going to be better for the same reason. What about a road race? There are lots of these around the country also. Regional races, national races. Our goal here is sustained high speed, no braking. Again, the aero wheel is going to be the wheel of choice. What about a time trial and a triathlon? Once again, aero. No question about it here that the aero benefit is more important than the weight penalty. We're going to look at this situation again soon, and we're going to look at center of pressure and when it's better to have different wheels on the front than you have on the rear. Now, criteriums are a very popular type of bicycle race in cities. They're a great spectator race also. In criteriums, our goals are speed and maneuverability and not crashing. Criteriums have a lot of corners. Here we see a 1K course, 1 kilometer course with 6 corners in it. There's lots of braking going into the corners. So which is best here? Is it the light wheel or is it the aero wheel? Well, here it depends. Am I mostly off the front or am I mostly in the pack? If I'm mostly off the front, then I am almost by definition, a faster rider. I'm going to be able to take corners better, less braking, and fewer crashes, maybe no crashes. What's better in that case is going to be the aero wheel. The aero wheel, we know, is going to have a higher energy of rotation. It's going to be higher with the aero wheel than it would be with the lighter aluminum wheel. But if I can keep my speed through the corners and I don't have to brake, then I don't lose that higher energy of rotation in braking. On the other hand, if I'm mostly in the pack, first of all, I have less head-on drag because I have other people around me, but I also have a lot of handling challenges that I don't have if I'm off the front. If I'm in the pack, the cornering is going to be defined by the pack. Every time I go around one of those 6 corners in that 1K course, I'm going to have to brake. And there's a lot more crashes in the pack also. Criteriums are very crash prone. What's going to be best for me there is going to be my lightweight aluminum wheel, which is also less expensive. And here's why. Because here I'm very concerned about the rotational energy. Because I'm having to brake when I go into my corners, whatever kinetic energy of rotation I have is going to be lost in those corners. It's going to be dissipated as heat. So those deep section carbon wheels, which are great for me in a road race, where I'm not braking and I'm not worried about losing my energy of rotation, they're a penalty here in a criterium because every time I go around a corner, I have to brake. I lose in the form of heat that energy of rotation, and I have to accelerate hard to gain it back again. Now, what about climbing and descending hills? Here's a scenario. You're on a ride and you meet a hill. The question is, it's a steep hill to climb and it's a steep descent on the other side of it. The question is, what should I do? Should I conserve energy climbing and hammer descending, or should I hammer climbing and conserve energy descending? Which is going to be better? And the answer is, I'm better off if I hammer climbing and conserve energy when I'm descending. And the reason is this: when I ascend, I'm riding at slow speed. So my aerodynamic drag is already minimal simply because I'm not going that fast. That means that if I put a lot of power into my pedaling, a lot of that power will actually go toward increasing my speed. On the descent, however, it's another story. I'm descending at high speed. My aerodynamic drag is large. If I try to put a lot more power into my pedals when I'm descending, I'm only going to see a small increase in speed because most of that increased power will just be wasted on overcoming the large aerodynamic drag that I see at high speed. I'm better off in that situation to focus on maintaining control of the bike and staying aerodynamic and not crashing on the descent. Another concept is that some people use the ride at isopower to ascend and descend with the same power reading. So if I'm ascending at 200 watts, I'm going to use my power meter to measure that. I'm going to try to descend at 200 watts also. People that have tried this have told me that they found that when they're not using a power meter and they start using one, they realize that by checking their power meter, they're realizing that they're just sort of goofing off and sandbagging on the descent, and that they should try to put in as much power going down the hill as up the hill, and consider that the descent is an opportunity to pick up speed, not a reward for having climbed up the first side of the hill. Think about this. Think about piloting your bike. And we'll go back to an airplane again. Airplanes are designed to fly at a certain airspeed. A given airplane will have a most efficient airspeed in terms of fuel consumption. So now let's say you're piloting the airplane and you encounter a headwind. You still maintain the same airspeed and power. Just because you have a headwind doesn't mean that you put the throttle forward to try to go faster into the headwind, because you would lose fuel efficiency. So you keep the same power setting and you just take longer to get there because you have a headwind. Try the same thing with the bike. Instead of fighting the headwind, just accept it. Say, okay, I have a headwind, I don't like it. I'm just going to ride more slowly. Everybody else has the same problem, and I'm going to let my power meter rule. I'm going to let my power meter tell me what is the most efficient power for me to ride at, irrespective of what speed I have based on wind conditions. Look at the wheel fairings on that airplane there to make the airplane more aerodynamic by blocking the drag that would otherwise be caused by the exposed tires. What about front and rear aero wheels? Here's another question. With side winds, which of the following is better? Is it better to have front and rear wheels of the same rim depths? Or is it better to have a front wheel deeper than the rear? Or is it better to have a rear wheel with a deeper rim than the front? The answer is it's better to have a rear wheel have a deeper rim than the front wheel. And if you look at that picture there on the right that we have seen a number of times before in the video, you'll see that for this rider, the depth of the rim in the front is less than the depth of the rim in the back. And there's a reason for it. It's not because he just didn't have two tires that matched. It has to do with what's called center of pressure. Now here's what we mean. Let's just talk about three different centers of pressure, A, B, and C, and you see that they occur at different places on the bike. And we'll look at them one at a time. A is a satisfactory location for the center of pressure. The center of pressure here is more toward the middle of the bike, somewhere around maybe the bottom bracket. This is going to give you an adequate handling of the bike if the center of pressure from a side wind is located somewhere around where A is pointing. Now, if I have the center of pressure where B is too far forward, B is too far forward toward the front of the bike, too much side pressure on the front of the bike, is too near the steering axis, which is, of course, the front wheel and the fork. And this is going to give me poor handling of the bike with a forward located center of pressure. If I have the center of pressure further back behind the bottom bracket, then I have a minimal force which is near the steering axis because it's aft or toward the rear of the bike. And this is going to give me optimal handling. If we look at some wheels, once again we're using Zipp as an example. Let's say you have a choice of all of these different wheels to put on your bike to give yourself a really nice handling, fast bike for a time trial or a triathlon. What would you pick for the front and the rear? The fastest setup is probably going to be to put a disc wheel in the rear. This is going to give you the maximum aero benefit in the rear, and it also will move the center of pressure toward the back of the bike, which, as we saw, is a good thing to do. Now, as far as the front wheel, is pretty much what you can handle. Deeper, of course, is going to be better. Deeper front wheel is going to be more aero. The only problem sometimes that people have with a little bit deeper section in the front wheel is side gusts. Experience, though, can help us deal with that. One of the problems with side gusts is that by definition you really can't anticipate them. You get hit with a side gust and you're constantly correcting. Typically what happens is we overcorrect, we get hit with a side gust, and then we correct for it, by which time the side gust is already gone. If you work on your technique, you can get better at handling side gusts in somewhat windy conditions.